Let's solve a system of 3 equations using matrices. So first, the system that we're going to solve is x plus 5y minus 12z equals 1, 3x plus 9y minus 21z equals 0, and 2x plus 4y minus 10z equals negative 2. So our first step is to write that as a matrix. So remember, in doing so, we want to use the coefficients and then the constants. So on the left side of our matrix, we are going to use the coefficients of each equation. So 1, 5, negative 12, and 1. We're going to put the constants on the right of that vertical line, just to keep it separate so that we know exactly what we're talking about. It's going to be very important that you can read your handwriting and you don't drop a negative. As soon as you miss a negative or lose a negative, it's just going to mess everything up. So we have ourselves a matrix. Now remember, the goal with these is that we want it to be a 1, 0, 0, some number on the right. So this is our goal. We want ones down the diagonal, zeros everywhere else. And that will tell me x equals, y equals, z equals. So we're going to manipulate these equations to get the numbers to look exactly like we want. I recommend you do column by column. So we're going to do everything for the first column, and then we'll move to the second, to the third, and call it a day. So our first step is to get a 1 in the first spot. Now, we are lucky enough to already be there, so we can move on to this next piece. To do that, we're going to take our first line and multiply by negative 3, add these two together. So if I take row 1 times negative 3, so that's my first step. Row 1 times negative 3 gives me negative 3, negative 15, 36, and negative 3. Then we're going to add to that row 2. Row 2 is 3, 9, negative 21, and 0. This gives me my new row 2. So in my matrix, row 1 and 3 stay exactly the same. 1, 5, negative 12, and 1. Row 3 is 2, 4, negative 10, negative 2. Those don't change. But when I add these together, that gives me my new row 2. So negative 3 plus 3 is 0. Negative 15 plus 9 is negative 6. 36 plus negative 21 is 15. And negative 3 plus 0 is negative 3. Now I have a 1. And then underneath that in the first column, I have a 0. That is my goal. Now I need to make this last 2 a 0. So I'm going to take this row 1, multiply by negative 2, then I can add them together. So row 1 times negative 2, okay, well, we go back to our row 1 and we multiply everything by negative 2. So I get negative 2, negative 10, a positive 24, and a negative 2. My current row 3 is 2, 4, negative 10, negative 2. So when I'm putting these together, row 1 and row 2 are not going to change. So row 1 is 1, 5, negative 12, and 1. And my current row 2 that I just found in the last was 0, negative 6, 15, and negative 3. Now I add these two together to get my new row 3. So negative 2 plus 2 is 0. Negative 10 plus 4 is a negative 6. 24 plus negative 10 is 14. And negative 2 minus 2 is negative 4. Great. We have successfully completed our first column. Next, we move on to column 2, and our first step is to get a 1 in that middle piece. We do that by dividing by negative 6. So my next step is to take row 2 divided by negative 6. So row 2, if you recall, is 0, negative 6, 15, and negative 3. So every one of these pieces is going to be divided by negative 6. In my matrix, rows 1 and 3 stay the same. So 1, 5, negative 12, 1. 0, negative 6, 14, negative 4. I am a big fan of rewriting the matrix every time because it's going to lead to fewer mistakes. So my new row 2, 0 divided by negative 6 is 0. Negative 6 divided by negative 6 is the one that we're looking for. 15 over negative 6, I can reduce that. These are both reducible by 3. So I get a negative 5 halves. And then on the right, negative 3 over negative 6 is a positive 1 half. Great. That's what I wanted, that 1 there. Now I want to move that -6 and I want to make it a 0. So I'm going to take row 2 and multiply by 6, which you might think this is kind of counterproductive, but it's a process, right? So we multiply by 6 and then add these together. So row 2 times 6 plus R3 is going to give me my new row 3. So my row 2 times 6 gives me 0, 6, -15, and a +3. My row 3 is 0, -6, 14, -4. So recall, we are messing with rows 2 and 3. Row 1 stays the same, 1, 5, -12, and 1. We are creating a new row 3. That means row 2 is going to stay the same, 0, 1, -5 halves, 1 half. Now when I add these together to get my new row 3, 0 plus 0 is 0. 6 plus -6 is 0. -15 plus 14 is -1. And 3 minus 4, or 3 plus -4, is -1. My goal of getting that to be a 0, complete. Now I'm going to work to make this 5 a 0. Right? So we're working our second column. So I'm going to take row 2, multiply that by -5, and then add it to row 1. So row 2 times -5 plus row 1 will give me my new row 1. Okay, so row 2 times -5. I'm going to have a 0, -5, 25 halves, and -5 halves. My row 1 is 1, 5, -12, and 1. Now at this point, I'm going to be dealing with fractions. So I do think it might be helpful to say, well, -12 is the same as -24 over 2, and +1 is the same as 2 over 2. Because I'm going to have to add fractions. So let's make our life a little easier if possible. We know row 3 is going to stay the same. 0, 0, -1, -1. And we're creating a new row 1. So our row 2 is going to stay 0, 1, -5 halves, 1 half. I add these together to get row 1. So 0 plus 1 is 1. -5 plus 5 is 0. 25 halves plus a -24 halves is 1 half. And then -5 halves plus 2 halves is -3 halves. Okay. These are looking pretty good. We have now successfully gotten our second column, right? Our first and second column are done. They're exactly what we want. So now we are going to the third row, and we want this to be a +1. So we can do that by just dividing by a -1. You could also multiply by a -1, either way. But in doing so, that leads us to a beautiful 1, 0, 1 half, -3 halves, 0, 1, 0, 3. Nope, I'm too far ahead. I'm ahead. Sorry, I get excited. 3 halves, we're dividing by -1. And then I have 0, 1, -5 halves, 1 half, 0, 0, 1, 1. So now we've successfully gotten a 1 there, and I'm going to work up to get those two to be zeros. So our first step then is to take row 3 times 5 halves, add it to row 2. So row 3 times 5 halves plus row 2 gives me my new row 2. So when I take row 3 times 5 halves, well, it's pretty easy. 0, 0, 5 halves, 5 halves. That's my kind of multiplication. Row 2 is currently 0, 1, -5 halves, 1 half. So when we look at what we have going on right now, row 1 is going to stay the same. 1, 0, 1 half, -3 halves. Row 3 stays the same. And now I add these to get my new row 2. So 0, 1, the 5 half plus -5 halves is 0. And then 5 half plus 1 half is 6 halves, which is 3. Great. I love this for us. Now we are ready to multiply row 3 by -1 half and add to row 1 to get rid of this piece. Okay, let's do that. Row 3 times -1 half plus our 1. So row 3 times -1 half is 0, 0, -1 half, -1 half. Row 1 is 1, 0, 1 half, negative 3 halves. So when I write my matrix, I have 0, 0, 1, 1. Then I have 0, 1, 0, 3. Add these together to get my new row 1. 1, 0, 0. When I add negative 1 half and negative 3 half, I get negative 4 halves, which is negative 2. We have now successfully gotten all 3 of our columns the way we want them. So when we look at our solutions, all right, so we have the matrix 1, 0, 0, negative 2. I don't know why all of a sudden my pen is fat. That's okay. And 0, 0, 1, 1. So as we look at this, we get excited. We say, okay, that means x equals negative 2, y equals 3, and z equals 1. Because that's what these represent. X, y, z, and the constant. So 1x is negative 2, 1y is 3, 1z is 1. And that is how you solve a system of 3 equations, 3 variables using Gauss-Jordan elimination, which is super fun stuff.